Hello everyone, myself Dr. Pallavi Nalle, Assistant Professor from the Department of Physics of Sri Shivaji Science and Arts College Chikhli, District Buldhana. Today I am going to present Microteaching for online refresher course in Advanced Instrumentation, which is held by Dr. Babasaheb Ambedkar Marathwada University, Aurangabad, UGC HRDC Department. I am going to present micro-teaching on topic solid state electronics devices second, which is one of the part of BSc Physics. Agenda or topics to be covered in this presentation are: first one, introduction to bipolar junction transistor, working of bipolar junction transistor and modes of operations. So we are going to see first point, that is introduction to bipolar junction transistor. So friends, transistor is a device which has three layers, and these three layers are of semiconductor. Means transistor is a three-layer semiconductor device. Okay. On the basis of construction, we can repeat one of the semiconductor material. Either it may be n-type semiconductor material or it may be p-type semiconductor material. If we repeat the n-type semiconductor material and we sandwich the p-type semiconductor material between two n-type semiconductor material, then such a type of fabricated transistor is called as NPN transistor. Okay. Why? Because P type of semiconductor is sandwiched between these two N type semiconductor. Then second possibility is that we can repeat P type semiconductor and N type semiconductor is sandwiched between P type semiconductor. Then such a type of construction is called as PNP transistor. Okay, got it? Means transistor are of two types. First one NPN transistor and second one PNP transistor. Next, these are the types of transistor. We see that already. First one PNP transistor and second type is NPN transistor. So when we draw a electronic circuit, then instead of writing the PNP transistor or NPN transistor, we use the symbol of that particular transistor. Okay, means when we are going to draw a PNP transistor, then we draw this symbol. This is the symbol of PNP transistor. Okay, and this is the symbol of NPN transistor. Okay, now that transistor have three terminals. First one emitter, second one base, and third one collector. Okay, in NPN transistor same case happens. We got three terminals. First one collector, then base, and then emitter. Okay, now what is the difference between these two transistors? The first one is the PNP transistor and second one is the NPN transistor. But how we differentiate these two transistors according to symbol? If in case of in case of PNP transistor, we draw a arrow which points towards the base terminal. Okay, means it indicates from emitter to base terminal. This is the direction of current, means current flows from emitter terminal to base terminal. Okay, and in case of NPN transistor, arrow is indicated towards the emitter terminal, means from base to emitter terminal. Current flows from base to emitter terminal, or you can simply remember it as current is flowing to positive to negative terminal. Okay, we all of know that current always flow from positive terminal to negative terminal. Okay, and in this PNP transistor, this emitter means p-type semiconductor, this base means n-type semiconductor, and this collector means again second p-type semiconductor. Means current flows from p terminal to n terminal. Okay, current flows from this p terminal to n terminal. Okay, and in case of NPN transistor, this collector terminal means n-type semiconductor, this base means p-type semiconductor, and this emitter means again second n-type semiconductor. In this case also, current flows from positive to negative terminal. Okay, current flows from positive to negative terminal means current flows from base terminal to emitter terminal. By using this simple trick that current flows from positive to negative terminal, we can remember the symbolic representation of PNP transistor and NPN transistor. Next, now we are going to see the bipolar junction transistor. Okay, bipolar junction transistor, or it is simply called as BJT. Okay, B means bipolar, J means junction, and T means transistor. This is the symbol of bipolar junction transistor. It may be NPN transistor or PNP transistor. Okay. Now, this is the symbol of transistor. This is collector, base, and emitter. And you always seen that device in your physics laboratory. This is the bipolar junction transistor, which having three terminals: terminal 1, that is emitter, terminal 2, that is base, and terminal 3, that is collector. Okay, two junctions, so transistor can be considered as two diode connected back to back. Okay, if we hide this n-type semiconductor, what we seen only two semiconductors, that is p-type, that is n-type semiconductor, and p-type semiconductor. Okay, if we hide this n-type semiconductor, we seen that this is p-type semiconductor and this is n-type semiconductor. Means what? Means two diodes are connected back to back. Okay, now this transistor has three terminals. We already talked about that. First one emitter, second one base, and third one collector. Now what happens in emitter? Emitter means it supplies charge carriers. Charge carriers are maybe electrons or holes. It supplies these charge carriers. Forward bias with respect to base, so that it can supply charge carriers, and in case of NPN transistor, emitter supplies holes towards the junction, and reverse of that, that is in case of PNP transistor, emitter supplies instead of holes electrons to the junction. This is the function of emitter terminal. Now what is the function of base terminal? Base terminal is always a middle section which forms two PN junction between emitter and collector. Okay, it is always a middle section. Now in case of collector, it collects charge carriers, reverse bias with respect to base, and in case of NPN transistor, what collector receives? What emitter supplies, means holes. Holes can receive through the collector to the junction, and in case of PNP transistor, what collector receives? Which was supplied by emitter, means electrons. Means collector receives the electrons which are supplied by the emitter towards the junction. This is the basic function of these three terminals: emitter, base, and collector. Now when we fabricate the bipolar junction transistor, we always think about the size and doping concentration of emitter, then base, and then collector. The size of emitter is always moderate, and in case of doping concentration, emitter is always heavily doped. In case of base, size is thin and always less doped. And in case of collector, collector size is always large and moderately doped. Now, this is the construction of PNP transistor. This p-type semiconductor is sandwiched between n-type semiconductor. Arrow away from the base. Arrow indicates conventional current flow, that is from base to emitter. We already seen that. In case of that NPN transistor, emitter emits electrons towards the base. Base push most of the electrons towards the collector, and collector collects more number of electrons which are emitted through the emitter. Now, in this diagram, we can see that biasing. Biasing takes place due to the transfer of resistance. Means what happens in biasing? In biasing, resistor is transferred. So that device is also called as transistor. Transfer of resistor, that is the transistor. Transistor action takes place, and this is the passive device. Okay. This is the construction of PNP transistor. Like the NPN transistor, p-type semiconductor is sandwiched between n-type semiconductor. Arrow towards the base. Arrow indicates conventional current flow from emitter to base. Emitter emits electrons towards the base. Then base push most of the collected electrons towards the collector, and collector collect more number of electrons. Okay, and this is the transistor biasing. Transistor biasing is necessary for the proper working of transistor. Means what we can do in the biasing, we can apply external batteries of correct magnitude and polarity should be applied across the two junctions. And on the basis of transistor biasing, we got two biasings. First one, forward biasing junction, which is called as forward bias, and CB junction, which is always in reverse bias. Thank you.